These are the most frequently asked questions for section 2.8 in Algebra 2. I'm going to start with number 15 because what usually happens here is somebody ignores this little negative that's out in front, and pretty obviously that's not something we can ignore. We have to deal with that. So to deal with it, what we do is we take that negative y is less than 2x plus 2, and we divide the entire equation by -1 or multiply by -1. It doesn't make any difference whatsoever. But when you do that, you have to remember to flip the sign. You must flip the inequality. So -2x minus 2, and it'll be y is greater than -2x minus 2. Now, then we just go ahead and graph it, which I don't think you're going to have a lot of trouble with, but I'll go ahead and do that anyway. So for number 15, we have, again, just to pretend, it says y equals -2x minus 2. So we go down on that y-axis 2 units, and then the slope would be a -2/1. So we would go down 2 and to the right 1. And again, you could do that a few times so that you get a good idea of where the graph is going to go. And you could even use the slope backwards, and go back off to the left here. But then what you want to do is stop pretending and realize, hey, this didn't have an equals bar. This one, I'm not supposed to include the solutions that are on that line. So this is going to have to be a dashed line. And then because I have this solved as y alone on one side, like y equals mx plus b, that means my solutions are here because it's going to be greater than. And you can always test that. I noticed that my shading there covers the point 0, 0, which is really nice to work with. So I put 0 in for x and for y, and I will get this. And this will say 0 is greater than -2, which it absolutely is. So I know that's correct. There's kind of a way to check and make sure that we've got our solving right and things worked out like they're supposed to. Obviously, that's not telling you that everything you did is right, but it's a way to check that you have your shading correct. Then, number 17 says the time needed to roast a chicken depends on its weight. At least 20 minutes per pound for a chicken weighing as much as 6 pounds. Allow at least 15 minutes per pound for a chicken weighing more than 6 pounds. Now, the reason A says that we have to write 2 inequalities is because there are 2 types of chickens here. There are the chickens that weigh as much as 6 pounds, and then there are those that weigh more than 6 pounds. So I'll have this first graph over here, and I'll have x stand for what we're doing here with that. If that x value, which is going to be the weight of that chicken, is less than or equal to 6 pounds, I'll put that on the first graph. And the other one will be for the chickens that are greater than 6 pounds. Now, I go back and figure out, well, what does the pounds, why does that matter? Because allow at least 20 minutes per pound for a chicken weighing as much as 6 pounds. That's these chickens over here. So what's going to happen is we're going to have to take 20 times the number of pounds, and it says at least 20 minutes per pound. So then we have to figure out, well, how do we make this work? Well, the time, y, and you read that off from the right-hand side this way, needs to be greater than or equal to 20 times the number of pounds. So I'm going to rewrite that one in this direction. Maybe it'll make more sense if you see it that way. The time needed to cook needs to be greater than or equal to 20 minutes per pound. Makes more sense, I think, if you turn it around backwards there. And then for the other chickens, well, then we know all we have to do is change that to 15. So now it's a matter of getting our units onto our graph so we can talk about what's going on. And we have time and pounds, So along the bottom, our x value dealt with how many pounds that chicken is going to be. And we're starting here with less than or equal to 6. So yeah, we might want to spread that out a little bit on this one. So maybe 1, 2, 3, 4, 5, and 6 pounds. because we want the ones that are 6 pounds or less for this graph. And then the time, well, you know, it's all going to depend on how many pounds they are, but if we put our 6 in for X, that would give us the highest amount of time for these chickens that are exactly 6 pounds. And that's going to be 120 minutes. So, let's see, I want to spread that one out pretty good. Let me have this be 20, 40, 60, 80, 100, and 120, so 120 minutes there. And then we could just graph this one using that slope of 20 if we'd like to, or we could put some points in. Obviously, if the chicken doesn't weigh anything, we don't have to cook it, so that'll be 0 right there. And then if we go ahead and put the 6 in, we know we have our 120, so that's probably the easiest way to get this one graphed. And this one, because it does have an equals bar, is going to be solid there. And again, we have it solved for y, so y needs to be greater than or equal to 20x. And as we look at that, we realize, okay, well, then that means we want to have that be greater than. And it might be another situation where you just want to test out a point just to make sure, you know? Like maybe I'll try 4 pounds in there and 0 minutes. Well, if I put 0 in there, it's going to say 0 is greater than or equal to 20 times 4. Pretty obviously, that's not what I want. So I do end up shading in this top area. It's just a quick way to double check that all the shading is going the right way. And I kind of wrote over the top of this one, didn't I? All right, so same thing with the other graph. Except this time we're talking about the hefty chickens. And again, we're going to have pounds on the bottom. And then time in minutes on the side. So I just need to see what's going on. And since this one is greater than 6, what I have to do is make sure that, you know, I give myself a little bit more room here after the 6. So why don't I go something along these lines? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Boy, a 20-pound chicken, that'd be something. 22, 24. So, massive chickens there. And we want this to be greater than or equal to 15x. So again, I'll start by putting a 6 in there. And that'll be a 90-minute cooking time. So I probably want to start maybe something down here like 40, 60, 80, 100, 120, 140. Because these are going to require, you know, a longer amount of cooking time. But notice it's less per pound. So again, if you put a 6 in there, you see that you get 90. So 6 and 90 would be right there. And then maybe I throw in something, you know, much higher to figure out what's going on. So maybe I do 24, you know, 24-pound chicken. Wow. All right, so 15 times 24 will give us 360. So that one's going to be off my chart a bit. Let me go back and try, like 15 times 12 and see if that'll fit on my chart here. So 15 times 12 is 180. So I will keep going here. So at 12, I have 180. And yeah, we could have used slope for this one too, you know, because it is 15 for the slope, so up 15 and over 1. So there is a line. And again, it's greater than or equal to, so we can realize that that's going to be up. And cook in that region right there. And like I said, I just always check a point. Like let's just say 18.0. Again, you know, it's pretty obvious right there. But if we put that in, you know, that's not gonna work. So it helps us figure out very easily whether or not we have done the shading correctly when we're talking about those problems. All right, then, the next one on the list that I thought you would need, let's see. Yeah, 25, why not? 25, I don't know that you really need on here, but I'm gonna go ahead and do this one anyway. And that's because 25 was not assigned, but it's very similar to what you have to do for number 24. So I didn't want to do 24 for you, but I'll go through and do 25. So the first thing I would need to do is to get this 1 over to the other side. So negative y is less than the absolute value of 2x minus 3 minus 1. And then that negative in front of the y can't be there. So I have to divide everything, both sides, by negative 1. And that will give me y, but remember, you have to switch the sign. So y is greater than the negative of 2x minus 3. Remember, that's our absolute value piece there, plus 1, because everything over there needs that negative 1. And again, you can think of it as multiplying by negative 1 if you want to. So now everything's been flipped around, and I have this nasty little 2 sitting in there. And remember, we want this to be y equals a, absolute value of x minus h plus k. So the next thing we would do is we would factor that 2 out. And then think backwards, 2 times x would give you 2x. And then negative 3 divided by 2 will unfortunately be a fraction, but it's not horrible. And then y is greater than negative 2, absolute value of x minus 3 halves, plus 1. And then we just need to graph that. So that means, I'll use this one as my x's and my y's here. That means our vertex is actually at 3 halves, 1. So 1 and a half, 1. There's my vertex. And then my slope for the right-hand side is down 2 and to the right 1. So we just count down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And again, we see what's going on. Now, that would be if it said equals. I would just fill that in for a solid line, but this one did not. So what I have to do is figure out those symmetry points on the other side. And this needs to be dashed. Not solid, because this said greater than. And when it's greater than, that's going to be above the boundary lines that we have here, or the boundary V that we have here. So again, you could test a point, and absolutely, especially on a test, I would encourage everybody to do that. Just pick something and see if it works. In this case, 0, 0 should work when we get done. So you can go back up to the original. 1 minus 0, is that less than the absolute value of 2 times 0 minus 3? Well, this says 1 is less than 3. Yes, that works. So that is the correct shading that we need there for number 25. And that's where I think I'm going to stop. I think with that, you'll be able to do number 24, at least I hope you will, and you'll be able to be successful with that.